76 million years ago, in the humid floodplains of what is now North America, a strange call echoed through the conifer forests. It didn't come from a throat. It came from a bone. A hollow, curved tube of bone, longer than a grown man is tall, growing backward from the skull of a plant-eating dinosaur. That dinosaur is Parasaurolophus, one of the most recognizable and most misunderstood animals to ever walk the earth. For over a century, scientists have argued about what that crest was for, what sound it made, and even how the animal held its head. And almost everything we know comes down to a handful of fossils dug out of the ground in Alberta and New Mexico that now sit in museum halls around the world. This is the story of those fossils. Our story begins in the summer of 1920. A field crew from the University of Toronto was working the badlands along the Red Deer River in Alberta, Canada, a stretch of eroded rock now known as the Dinosaur Park Formation, one of the richest dinosaur graveyards on the planet. Sifting through Late Cretaceous sediment near Sand Creek, the team uncovered something unlike anything they had catalogued before. A partial skull and skeleton, missing its lower legs and most of its tail, but with a crest unlike any dinosaur skull yet known to science.
The specimen was brought back to the Royal Ontario Museum, where preparators spent years cleaning and mounting it in the distinctive wall panel style you see here, a technique common in early 20th century museum work, embedding the bones in a sculpted rock matrix rather than a freestanding armature. This specimen was catalogued under the number ROM 768, and it would go on to become one of the most important type specimens in all of dinosaur paleontology. In 1922, paleontologist William Parkes of the University of Toronto formally described ROM 768 as a new genus and species, Parasaurolophus walker. The genus name means near-crested lizard, a nod to Saurolophus, a solid-crested hadrosaur described a few years earlier, which this new animal superficially resembled. The species name, Walker, honored Sir Byron Edmund Walker, chairman of the Board of Trustees at the Royal Ontario Museum. What set this animal apart immediately was that crest, a hollow, tubular structure sweeping backward off the skull roof, unlike the solid crests or flat heads of other duck-billed dinosaurs known at the time. ROM 768 remains the holotype of Parasaurolophus walkeri to this day, and it is still held at the Royal Ontario Museum in Toronto, the benchmark against which every other Parasaurolophus fossil is compared. So what exactly was inside that crest? Early reconstructions guessed at everything from a snorkel to a weapon. But when scientists CT scanned and dissected the internal anatomy, the answer turned out to be far stranger and far more elegant. The crest was hollow, and inside it ran a set of looping airways, extensions of the animal's own nasal passages, folded back on themselves like a brass instrument. Air breathed in through the nostrils didn't go straight to the lungs. It traveled up through the face, into the crest, looped through several internal chambers, and only then descended back down the neck to the throat. In effect, every Parasaurolophus carried a built-in wind instrument on top of its head. That internal plumbing is exactly why paleontologists believe the crest functioned as a resonating chamber, a sound-producing structure not unlike a trombone or a didgeridoo. By forcing air through those looping nasal passages, Parasaurolophus could likely have produced a deep, low-frequency call, audible over long distances through dense floodplain vegetation.
Researchers have built digital and physical models of the crest's internal air chambers and used them to estimate the kind of sound the animal could produce, a resonant, foghorn-like moan. It's a strong hypothesis for how these animals communicated across a landscape shared with predators like Daspletosaurus and Albertosaurus, using their own skulls as a herd-wide alarm system, a mating call, or simply a way to stay in contact with the group.
ROM 768 turned out not to be the only member of this genus. A year after the Alberta discovery, in 1921, fossil collector Charles H. Sternberg found a partial skull nearly 2,000 kilometers to the south in the Kirtland Formation of New Mexico. That skull was sent across the Atlantic to Uppsala, Sweden, where paleontologist Carl Wieman studied it for a decade before formally naming it in 1931 Parasaurolophus tubicin, the trumpeter. Wieman chose that name because the internal architecture of the crest reminded him of a coiled brass instrument.
That original skull, now catalogued at Uppsala University, was for decades one of the only clues to this second species. It wasn't until 1995 that a second, much more complete P. tubicens skull, designated NMMNHP25100H and now housed at the New Mexico Museum of Natural History and Science, was unearthed, allowing researchers to finally CT scan a fully intact crest and confirm just how complex and elongated the internal airway system of this species really was. P. tubicen turned out to be the largest of the three known species, with the longest, straightest crest of the genus. A third species emerged from the same region of New Mexico. In 1923, Charles Sternberg recovered a partial skull and a fairly complete postcranial skeleton from the Fruitland Formation. This specimen sat unstudied for decades until 1961, when paleontologist John Ostrom described it as Parasaurolophus ceatocristatus, meaning curved crest. The holotype, catalogued as FMNHP27393, is now housed at the Field Museum in Chicago.
Unlike the long, gently sweeping crests of P. walkeri and P. tubicin, this specimen's crest curved sharply downward at the back, short, stubby, and dramatically hooked. For years, some researchers wondered whether this really represented a separate species at all, or simply a younger individual, or even a female of one of the other two species. Later discoveries of additional Cytocristatus material, including a skull found in Utah's Kuiperowitz Formation and described by David Weishampel and James Jensen in 1977, catalogued as BYU2467, helped confirm that the short, curled crest was a genuinely distinct and stable feature of its own species.
One complication these three species created was the discovery that a Parasaurolophus crest didn't stay the same shape throughout its life. Juvenile individuals had small, rounded crest buds. As the animal aged, the crest grew longer, straighter, and more complex on the inside, meaning a young adult and a fully mature adult of the very same species could look, at first glance, like they belonged to two different ones. This growth pattern is part of why crest shape alone, without other skeletal evidence, can be a surprisingly unreliable way to sort out species. Look closely at any mounted Parasaurolophus skeleton, and you'll notice something interesting about the front limbs. They're relatively slender compared to the powerful hind legs, but they were still robust enough to bear weight. This has fueled a long debate. Was Parasaurolophus primarily bipedal, rearing up on its hind legs to browse and to run? Or did it spend much of its time on all fours, grazing low vegetation like a modern-day quadruped? The current consensus, supported by trackway evidence from related hadrosaurs, is that Parasaurolophus was likely a flexible, facultative quadruped, capable of dropping onto all four legs to feed or move at a walking pace, but able to rise onto its hind legs for a fast escape from predators, using its long, stiffened tail as a counterbalance. In 2020, a century after its discovery, ROM 768 gave up one more secret. A detailed study led by paleontologist Filippo Bertozzo at Queen's University Belfast examined the original holotype bone by bone and found something remarkable. Clear evidence of trauma. Several ribs showed healed fractures. The jaw showed signs consistent with periodontal disease, and a strange gap between the neural spines along the back, long debated by earlier researchers, was reinterpreted as scar tissue from a serious injury the animal survived.
The leading theory is that this individual was struck by something heavy, possibly a falling tree during a storm, sustaining injuries to its side and back that it lived through for weeks or even months before eventually dying. It's a rare, direct window into the hardships of an individual animal's life, preserved by chance in the very bones that first introduced this genus to science 100 years earlier. So what did Parasaurolophus actually look like, alive, day to day? Based on skin impressions preserved alongside the ROM 768 skeleton, one of the few direct fossil records of this animal's skin, we know it was covered in small, uniform, pebble-like scales, not the smooth or feathered skin sometimes shown in older reconstructions. It stood on four muscular legs when at rest, with a long, deep tail and a thick, powerfully muscled neck needed to support the weight of that crest. Modern paleoart increasingly shows Parasaurolophus with a stockier, more muscular neck than the swan-like curve popularized in mid-20th century illustrations, a correction driven directly by that 2020 anatomical study, which argued the neck needed serious muscle and ligament support just to hold the crest upright. Fully grown adults are estimated to have weighed somewhere around 5,000 kilograms and measured roughly 9 to 10 meters from snout to tail tip. Comparable in size to a large modern elephant, but built like a dinosaur. Lightweight, hollow-boned in the skull, and remarkably efficient at eating. Inside that long, flattened beak sat one of the most efficient chewing systems in the entire animal kingdom, a dental battery made up of hundreds of tightly packed, continuously replaced teeth. As one tooth wore down from grinding tough Cretaceous vegetation, another was already growing in to replace it, a conveyor belt of teeth that let Parasaurolophus process enormous quantities of plant matter every single day, fueling that multi-ton body. Displays like this one place Parasaurolophus alongside its late Cretaceous neighbors, the horned ceratopsians it shared its floodplain habitat with, all competing for and dividing up the same lush vegetation along ancient river systems. More than a century after that first skull was pulled from the banks of the Red Deer River, Parasaurolophus remains one of paleontology's best case studies in how much a single, well-preserved fossil can teach us, not just about anatomy, but about behavior, sound, growth, injury, and survival. 3 species, 3 type specimens, ROM 768, PMU 24921, and
FMNH P27393, and decades of careful, painstaking research have turned a single strange skull into a genuinely three-dimensional picture of a living, breathing, calling animal. The next time you see that unmistakable curved crest in a museum hall, in a book, or on a screen, you're looking at one of the clearest examples in all of science of how much can be learned from bones alone.